Alrighty, in this video here, we're going to conclude chapter 11. So we're going to stop here on chapter 11, which is going to be lesson 11.5. The rest of this chapter 11, if you ever get to take a course called linear algebra, you'll see more of this applied. We're just trying to give you the basics of matrices, and then it goes a little bit further in Calc 2 and in linear algebra. But then after this, we'll skip to chapter 12 and then go through the first three sections there. And that will pretty much be the conclusion of this course. But for today, we'll be talking about lesson 11.5, inverses of matrices. Alrighty. So some of the facts that come out of the lesson, be on a reminder here from previous lessons. If I have a two variable equation in the form of ax plus by equals e, and I have cx plus dy equals f, I can convert that into a augmented matrix, which look like this: a, b, c, d, e, f. All right, so this is what we have learned. And in this chapter or this lesson, we can go a different direction with this. This would then be the same thing as A, B, C, D times X, Y equals E, F. And if you don't believe me, if you do the row times column that you learned in the previous lesson, A times X is AX, B times Y is BY, and we add the products, and then it equals my E. And then this is CX plus DY equals F. So this right here is the same as this. So this right here is where we're going to be at for this lesson. So the next thing you need to know is an identity matrix, what it looks like. The identity matrix is basically a matrix with a diagonal of ones and triangles of zeros. So this can be for a two by two, it's written like this. A 3 by 3 is written like this. A 4 by 4, if you happen to get one of those. So on and so on, right? So identity matrix is basically a diagonal of ones with triangles of zeros. And what the purpose of that identity matrix is, if you take an identity matrix and multiply it to any matrix, you just get the matrix back. So this allows us to be able to have an identity matrix for multiplication. We also have a new notation here. So for inverse, it is noted as a raised to the negative one. So when you see this, it is looking for the inverse. And with that, we can conclude that A times A inverse is commutative in this situation. So therefore, A inverse times A will both equal the identity. So A inverse and its original matrix multiplied together in any direction will give us the identity matrix. That's how you can tell if something has an inverse to check your work. All right, as always, we have formulas for a 2 by 2, and then we have ways to do n by n's. So formula way to find a 2 by 2 inverse. So if A is equal to A, B, C, D, then A inverse would equal 1 over the determinant, which was A, D minus B, C, times, you're going to switch the places of your A and D. So this is now D, this is now A, and then you're going to change the signs of your B and your C. So big note here, this diagonal, I'm just changing the signs, not the C and the B itself. This one, I'm just changing the A and the D, but I'm not changing the signs. All right, and then with that, we could calculate what the inverse would be. A little extra note here, I'll add it to the bottom of this one. If AD minus BC, the determinant, is equal to 0, it is not invertible because you can't divide by 0. So therefore, if you do get AD minus BC equal to 0, then that 2 by 2 matrix does not have an inverse. Alrighty, for anything bigger, than a 2 by 2, so for n by n's, that's not a 2 by 2, we'll use this method. You'll make a matrix with your matrix and then a division or a such that bar and have the identity. And then we will do row reduced echelon form to basically then move the identity to this side and have our inverse on this side. And I'll show you what that means. There's an example for it. But basically, again, you plug in all your numbers here, row reduced echelon form to get it to this form. And then whatever ends up happening over here, that would be the inverse. And then the last thing we're going to be doing is using inverses to solve matrices. So for example, if AX equals B, meaning we took something like the previous thing and we have A, B, C, D times X, Y equals E, F. So this would be your A, this would be like your X, and this would be your B. So this is what I mean by saying this right here. So if this, then I can take the inverse of A on both sides. But notice I did the inverse of A on the left side of A. So I must also do it on the left side of B. And you'll note if you try to do it on the right, it will be an improper matrix and it won't be able to multiply. This is a 2 by 1 and the inverse would be a 2 by 2. So if I try to multiply it on the other side, a 2 by 1 and a 2 by 2 won't happen. So I have to put it on the left side so a 2 by 2 and a 2 by 1 can be multiplied. Now, when you do this, we just saw that A inverse times A gives you the identity matrix. And then we now know the identity matrix multiplied to any matrix will just be that matrix. So there you go. So then your values of X and Y will be whatever the resultant of the inverse of A times the B, which again, the B would represent the what it's equal to. All right, and that would pretty much wrap up everything in chapter 11.5 and pretty much everything in chapter 11 that we're going to cover. So let's do examples so that y'all have plenty of examples for the homework. So we're going to start off with number 1. Number 1 is given to you as 14x minus 5y equals 7. And then x plus 9y equals 2. We're going to write each of the following system of equations as a single matrix. So that's all you got to do on the first type of problem. So when I do that, what it's asking for is I'm going to write out all the coefficients of x and y. So this would be 14, negative 5, 1, because there's like an imaginary 1 here, 9, and then I would write x and y equals what it's equal to. So in this case, 7 and 2. And that's all you have to do to begin with. Right? So turning a equation into a system of matrices. All right, so let's do a couple more. They do make it more challenging. So let's look at number 10. All right, number 10 is negative 7 over 3y equals 5 minus x over 6. And then we have x minus 5 times y minus 3 equals -2. So we have to make sure it's in what we call standard form of the ax plus by equals e and the c x plus dy equals f format. So what I'm going to do is I'm just going to work them out. All right, this is -7/3 y equals, I'm going to separate this as 5/6 minus, oh, minus 1/6 x. So therefore, again, there's like an imaginary one here, so I can separate these, and then now I can add it over. And when I do that, I would get a positive 1/6 x minus 7/3 y. Notice I wrote the x term first equals 5/6. So I now have this one in the correct format. Now I need to do the same thing to this one. Here, I'm going to take the -5, distribute it. So I get x minus 5y plus 15 equals -2. X and y is on the right side, but I need to get rid of this constant. So I'm going to subtract 15. So I get x minus 5y equals -17. Now that I have it in the correct format, I can now write the coefficient. So I can do 1/6 -7/3. Remember, there's an imaginary one here. 1 minus 5, or 1 and -5, x, y, and that would equal 5/6 and -17. Right, so they do try to make it a little bit more challenging. It's hard to make those type challenging, but they do it in this way to kind of work it out for you. Mhm. Let's look at another one. Let's look at number 11. So this right here would be 2x minus y equals -3z. Y minus x equals 17. 2 plus z plus 4x equals 5y. As I write this, I'm thinking about this other problem. This one's completely correct, but you might see it where they want to get rid of fractions. And so what you can do is you can do it here or you can do it here. You can get rid of the fractions by multiplying by the denominator of 6, giving you the x minus 3 goes into 6 2 times, giving you 14y equals 5. So if you wanted a cleaner version, you could write it as 1 -14, 1 -5, xy equals 5 -17. Both of these would be correct. But I feel like I remember seeing something else homework that wanted it without like fractions or something, like it made a statement. So if it says something like that, to get rid of the fractions, as long as you multiply everything in that equation, even though this is correct answer, this would be a correct answer as well. Now, this just popped up in my mind. All right, here, let's continue the same process. Remember, the standard form for three variables is x, y, z. So I just need to write these in the correct form. Oh, all right, switch colors. All right, so I'm going to add the 3z over. So this gives me 2x minus y plus 3z, but then there'll be nothing left over here. So I would say equals 0. This one here, I'm going to write it as -x because, again, I have to have it in the correct form, plus y plus 0z. Now, I rewrote this one, so I had a placeholder for it and didn't forget it. This one is going to be 4x. And that was going over there. This one needs to go over here where this constant needs to be moved over here. So when I move this positive 5y over, it becomes a -5y plus z equals this positive 2 moved over becomes a -2. Now I'm ready to write it out. So this will be 2, -1, 4, -1, 1, -5, 3, 0, 1. And this would be x, y, z. And this will be 0, 17, -2. And there you go. So hopefully not too difficult, a little fun, find it fun. And then I didn't write any extra notes, so that's how they liked it on the note homework. All right, so then let's get into a different type of question. Let's look at number 13. Number 13 says find the inverse of each of the following matrices if possible. So we are given 0, 4, -5, -1. All right, remember to find the inverse, I need to find AD minus BC first. So I label this as A, B, C, D. I get this a lot as well. Does it matter if I put the B here? What if I go A, B, C, D and I label it that way? Technically, because you're multiplying the B and the C and only changing the sign of the B and C, that part will not matter. So if you do label it as A, B, C, D, you'll still get the same outcome. So don't stress about, oh, I need to make sure I go this way. It actually ends up working out in both directions. All right, so this would be 0 times -1 minus 4 times -5. So in this case, that's 0. So this is -4 times -5, which is 20. This not being 0 tells me there is an inverse. So to find the inverse, I'm just going to label it as this so we have the correct notation. I'm going to do 1 over 20. And then I'm going to switch the places of my D and my A. So this becomes a -1. This becomes a 0. And then I'm going to change the sign of my B and my C. So this becomes a +5 and a -4. After this point, all you got to do is just distribute it. So you're going to distribute this 1 over 20 into the question. And you would get -1 over 20. And then you want to simplify. 4 goes into 25 times. So that's going to be -1/5. 5 goes into 20 4 times. So that'd be 1/4. And then 1/20th times 0 is 0. And then that would be your answer. So when you are multiplying this fraction, make sure you're simplifying at the same time, or you multiply and then simplify in the next step. But this would be the inverse of number 13. All right, let's do another one. Let's look at number 14. This one is -2, -2, -1, and 2. So again, the first thing I'm going to do is determine my determinant, which is AD minus BC. So that's going to be -2 times 2 minus -2 times -1. So this right here would give me -4. This would be -2 times -1, which is 2. So that'd be -2, which gives me -6. So then you take that, and I didn't get 0. So therefore, my inverse here would be 1 over -6. I'm going to switch the places of my A and my D. So the 2 goes here, the -2 goes here. I'm going to change the sign of my B and my C. So this becomes a 1 and this becomes a 2. Then I'll multiply it out. So 2 times -1, 6 gives me, or 2 goes into 6 3 times. So that's -1/3. 2 goes into 6. So that'd give me -1/3. That would just be -1/6. And that would give me a +1/3. And there's your inverse there. All right, let's do another one. So let's look at number 15. Number 15 is 3, 4, -4, -5. Again, I start with the AD minus BC. So this would be 3 times -5 minus 4 times -4. So this will give me -15. And then -4 times -4 actually gives me a +16. -15 plus 16 gives me 1. So when I find the inverse, I would do 1 divided by 1, which in reality is just going to be 1. So the moment I switch these two guys and change the sign of these guys, there would be my answer. So I'm just going to rewrite it. So -5, -4, 4, and 3. Right? So those are the nice ones. But that would be the inverse there. All right. So let's do a 3 by 3. This is probably going to be like the hardest one, just because it goes back to doing that row reduced echelon form. All right, so number 19. you are given -2, -4, -2, 1, -4, 1, 4, -3, 4. All right, so to do this with a 3 by 3, I'm do a different color here, orange. All right, so that's going to be -2, 1, 4, -4, -4, -3, -2, 1, 4. Separate it, and then I'm going to do the identity for a 3 by 3 matrix. All right, and my goal is to make this look like the identity matrix. And when I'm done, whatever this is going to be my inverse. So let's get right to it. If you remember the process, the goal is to make this a 1. So I'm going to do row 1 divided by -2 gives me row 1. So that would be 1, 2, 1, -1/2, 0, 0. And then I'm just going to rewrite these. All right, my next goal, I can do these 2 steps at the same time. Make this a 0. So to do that, I'm going to do negative row 1 plus row 2 gives me row 2. You could have said row 2 minus row 1. It doesn't really matter. And then I'm also going to do -4 times row 1 plus row 3 gives me row 3, so that I also make this guy 0. So here we go. I write the first row as is. Not going to change it right now. And then when I do this, so the first step, -1 plus 1 gives me 0. -2 plus -4 gives me -6. -1 plus 1 actually gives me 0. -1/2 would be +1/2 plus 0 would be +1/2. 0 plus 1 would be 1. 0 plus 0 would give me 0. Do the same thing to the bottom now. -4 plus 4 is 0. -8 plus -3 would give me -11. A -4 plus 4 gives me 0. -4 times -1/2 is 2. 2 plus 0 is 2. 0 plus 0 is 0, and 0 plus 1 is 1. All right, so now the next step is to make this guy a 1. So on this one here, I'm just going to do row 2 divided by -6 to get row 2. That's 1, 2, 1. -1/2, 0, 0, 0, 1, 0. Okay, so 1/2 divided by -6 is actually -1/12. Because keep change flip. And then so 1 divided by -6 is going to be -1/6. And then 0 divided by -6 is just 0. And then the goal now is to make this guy a 0. So to do that, I'm going to take row 2 and I'm going to multiply it by 11. So row 2 times 11 plus row 3 will give me a new row 3. All right, so if I do that, so 11 times 0 plus 0 is 0. 11 times 1 plus a -11 is 0. 11 times 0 plus 0 is 0. And then we have a -11/2 plus 2. Okay, so that's -11/2 plus 2. So that would be the same thing as 4. So that would be -7/2. Yep, okay, -7/2. And then 0 plus 0, and then 1. And then this would be 0, 1, 0. And then this would be -1/12, -1/6, 0. And then this would be Could I do anything here? I could. I'm going to go ahead and I'm also going to turn this into a 0. And so by doing that, I'm going to say this is going to be -2 times row 2 plus row 1 gives me row 3. Okay. Nope. I lied. Row 1. All right. So -2 times 0 plus 1 is 1. -2 times 1 is -2 plus 2 is 0. -2 times 0 plus 1 is 1. -2 times -1/12 is actually positive 1/6. 1/6 plus -1/2. That would be the same thing as -3/6. So positive 1/6, -3/6. That'd give me -2/6, which is -1/3. Again, you could type these in the calculator. I'm good with that. This will give me positive 1/3 plus 0. This will give me 0 plus 0, which is 0. All right, the only move I have left is I need to turn this guy into a 0. And I don't think I can. Unless I switch. Yeah, I think this is one of those special cases. I should have figured that out a long time ago. The moment I got to this point right here, when you end up with a row that ends up being all zeros, it ends up being not invertible. But it's okay. Again, had this all ended up working out, give me ones, what this would have been the inverse of that function. So the moment I got 1, 1, 1, made that a 0. I can't do anything to make that a 0. But while you're working these out, the moment you get one row on the left side with zeros, it becomes not invertible. So I'm glad we kind of did this in both ways. It kind of, just in case you see one that's like that, and also kind of we almost made it to the end if we could have had another number there. All right, so this is probably again your hardest one just because there's goes back to that row reduced echelon form. All right, so let's do another type. Let's look at number 37. This is the last type, but we'll make sure we do plenty of examples. Here it wants us to solve the following solve the following equations using the inverse method. So we know many methods, but this one specifically wants us to use the inverse one. So -2x minus 2y equals 9. -x plus 2y equals -3. So I'm going to write this out as my matrix equation. So this would be -2, -1, -2, 2 times xy equals 9, -3. So what we've seen is basically we find the inverse of this guy and multiply it to this guy, we have our answer. So that, and I'm going to call this A. So I'm going to look for the inverse of A. And by doing that, the first thing I need to do is AD minus BC. So in this case, that's going to be -2 times 2 minus -2 times -1. That would give me -4, and that would give me -2. So that would give me -6. So in this case, this would equal 1 over -6. Switch the places of your A and D. So this is now a 2. This is a -2. Change the sign of your B and C. So this is a 1 and this is a 2. Now, this is what I recommend. Once you have the inverse, now take your B, which is 9 and -3, multiply these out first, then apply the fraction so you don't have to deal with fractions until the very end. So I'm going to do row times column. So that's going to give me 2 times 9, which is 18, plus 2 times 3, which is 6. And then row times column. 1 times 9 is 9. -2 times -3 is 6. That would give me 12 and 15. And then now you distribute. So this will give me -2 and -15 over 6. Okay, they got 5 halves. 15 over, oh, because 15 over 675 is down by 3. So that would be 3 goes into, I didn't even see that. I was like, oh, it's prime. 15 isn't. So that's 3 goes into 15 5 times, 3 goes into 6 2 times. All right. Always try to reduce your fraction if you notice it. All righty. So let's do another one. So you can kind of follow the pattern pretty good. So let's look at number 38. So we get 3x plus 4y equals -2, and then -4x minus 5y equals 9. Again, I'm going to rewrite this. So it's 3, -4, 4, -5, x, y, -2, 9. Remember the pattern here. Find out your AD minus BC. So in this case, that would be 3 times -5 minus 4 times -4. So that's going to be -15 plus 16, which is a nice 1. So when I find this inverse, that's 1 divided by 1. Switch the A and the D. So this is now -5. This is 3. Change the sign of B and C. So this is now 4, and this is -4. When I work this out, it's really just going to be the same matrix. I feel like we did this earlier. Maybe not. Now take that and now multiply it to your B. So -2 and 9. So -5 times -2 is 10. -4 times 9 is -36. 4 times -2 is -8. 3 times 9 is 27. Combine those. So that gives you -26 and 19. There you go. All right, so let's do one more to give you just another example to make sure you fully understand what's going on. So let's look at number 39. This is -2x plus 3y equals 1. And this is 4x minus 6y equals -2. Again, I'm going to rewrite this as -2, 4, 3, -6, x, y equals 1 and -2. All right. So when I work this out, I'm going to do AD minus BC first. So this is going to be -2 times -6 minus 3 times 4. -2 times -6 is 12. Minus 12 gives us 0. So remember, if I get a determinant that's 0, it is not invertible. And in this situation, I cannot use inverses to solve this. All right, so this is what we got to do. All right, so they want you to go further with it. Okay, so this is what you'll do. Make it as easy on you as possible. When this happens, solve for any letter, right? So let's take -2x plus 3y equals 1. You can solve for x or y. It doesn't matter. I'm going to solve for y to get this in like slope. No, I'll solve for x. It doesn't really matter. I'm going to subtract 3y. So I get -2x equals -3y minus plus 1. And then I'll divide by -2. So therefore, x equals -3y plus 1 over -2. Once you have 1 solved for, then this is how they want you to write the answer. And again, you could solve for y as well. But since I solved for x, I'm going to say it's -3y plus 1 over -2, comma, y. So whatever y is, I will know x. If I would have solved for y, I'll show you that here in a second. So alternatively, if I wanted to, I could have solved for x. So -2x plus 3y equals 1. I'll add 2x this time. So 3y equals 2x plus 1. Divide that by 3. So y would equal 2x plus 1 over 3. So alternatively, I could have also written x, comma, 2x plus 1 over 3. Basically just saying whatever y is, I now know my x. Whatever x is, I know my y. And then the only thing they add extra to this is this little notation as such that y has to be a real number. Same thing here, x such that it has to be a real number. And it's the only thing they add in there. So when you end up with this non-invertible, do a little algebra and then get it to this point. All right, so I'm glad we got finished off with that case. There should be no surprises, but as always, if you need more examples, just let me know. See you in the next video.